Gravity feels constant. But if it weakened by just 1%, the first thing to break wouldn't be the ground beneath your feet. It would be the sky above your head. Gravity is the invisible force holding everything together. Your body, the oceans, the atmosphere, and even the moon in the sky. We think of it as unchanging, permanent, untouchable. But today, we're asking a very specific question. What if gravity didn't disappear? What if it weakened by just 1%? Would you even notice? Would life feel different? Or would that tiny change quietly trigger a chain reaction far bigger than anyone expects? Because when it comes to gravity, small changes don't stay small for long. What does 1% less gravity actually mean? Let's start by clarifying something important. This isn't science fiction where gravity suddenly shuts off. This is far more subtle and far more realistic. A 1% reduction in gravity means that every object on Earth experiences 1% less downward force. If you weigh 80 kilograms, gravity is what pulls that mass downward. Reduce gravity by 1%, and suddenly, you weigh about 79.2 kilograms. Not dramatic, not noticeable. At least, not yet. But gravity doesn't just affect your weight. It governs how air stays bound to Earth, how water behaves, how satellites stay in orbit, and how stable our entire planetary system is. And that's where things begin to change. The human body, under weaker gravity. At first, life feels normal. You stand up, you walk, you breathe. But subtle differences begin to emerge. Your muscles and bones evolved under Earth's precise gravity. Reduce that force, and suddenly your body doesn't need to work quite as hard. Jumps feel slightly higher. Movements feel slightly lighter. Long-term, bones lose density just a bit faster. Muscles weaken just a bit more over time. Astronauts in microgravity lose bone mass rapidly. This isn't that extreme, but it's a step in that direction. You wouldn't notice in a day, or a week, but over years, entire populations could experience higher risks of osteoporosis and muscle degradation. A tiny force, slowly reshaping biology. Now we move from the human scale to the planetary scale. The atmosphere begins to change. Gravity is what keeps Earth's atmosphere from drifting into space. Air molecules are constantly moving, fast, chaotic, energetic. Gravity is the leash holding them close. When gravity weakens by 1%, that leash loosens. The atmosphere doesn't vanish, but it expands. Scientists call this the scale height of the atmosphere, essentially how tall it stretches before thinning out. With weaker gravity, the atmosphere becomes slightly taller. Air spreads farther upward. The outer layers become easier to strip away. This makes Earth more vulnerable to solar winds, cosmic radiation, long-term atmospheric loss. It's not an apocalypse, but it's the first crack in Earth's protective shell. Oceans, pressure, and boiling water. Gravity also controls pressure. Air pressure exists because gravity pulls air downward, stacking it layer by layer. Reduce gravity and surface air pressure drops. That means something strange happens. Water begins to boil at lower temperatures. At sea level today, water boils at 100 degrees Celsius. With slightly weaker gravity and lower pressure, boiling happens earlier. Not enough to ruin cooking, but enough to affect weather systems, evaporation rates, storm formation. Oceans don't spill into space, but the balance between air, water, and heat begins to shift. Subtle at first, but climate systems are sensitive, and sensitivity is where chain reactions thrive. Introducing the problem. challenge. Up to now, everything we've discussed happened slowly, quietly, almost invisibly. But gravity doesn't only act on Earth, it acts on everything orbiting Earth. And that's where the real problem begins. Satellites and the fragile balance of orbit. Satellites don't float in space. They are constantly falling toward Earth. They just move forward fast enough to keep missing it. This balance depends on gravity being precisely what we expect. If gravity weakens by 1%, suddenly, orbital speeds are slightly too fast. Satellite paths become unstable. Orbits stretch and drift. Some satellites move into higher, slower orbits. Others lose synchronization. GPS systems rely on extreme precision. A tiny error in orbit means navigation drift, communication delays, military and civilian systems failing silently. No explosion, no warning, just systems slowly going out of alignment. The moon and the tides. Now let's look up. The moon doesn't just orbit Earth. It stabilizes Earth's rotation and controls ocean tides. Tides exist because of the gravitational pull between Earth and the moon. If gravity weakens, tides become weaker. Coastal ecosystems change. Ocean circulation patterns shift. Tides are part of how Earth redistributes heat. Weaker tides mean less mixing of ocean layers, altered climate feedback loops, changes in marine life migration. Again, nothing dramatic, but nothing stays isolated. Climax. Key moment. Here's the part most people miss. Gravity isn't just a force, it's a constraint. It limits how fast things move, how far they spread, how stable systems remain. Remove just 1% of that constraint, and complexity begins to unravel, not with explosions, not with chaos, but with quiet drift. Atmospheres expand, orbits stretch, biology adapts or fails, and humanity might not notice the moment it happens, only the consequences. Summary. What if gravity weakened by just 1%? Life wouldn't end overnight. On the contrary, your life would change. This effect would last for a long time. Earth's stability would weaken in the long run. And finally, what if the percentage was 20% instead of 1%?